So I'm a little late to the party as usual, especially when it comes to Intel's new launches, the 7960X and 7980XE. Well, you know what I think is funny about that naming convention, first of all, is the X always meant extreme, but then they called all of their 299 CPUs X, but they're not all extreme, so they put the E in there. So now it's Extreme Edition, whatever. I digress. We're gonna be taking a look at a little bit of that today, but this is not a full review of that CPU, and I wanna make that first and foremost clear because I've been working on other projects. I'm late on that, but I wanna see what happens here if I install a 7980XE into my test bench here, which has what looks like is going to be an undersized power supply. It's currently running one of the Gigabyte 800 watt power supplies. And if you couple that with something like a single GTX 1080, which when overclocked can take about 300 watts of its own power, leaving about 500 max output capability, what happens now when I leave only 500 watts left to the CPU when we've seen that when you start to overclock it, it pulls more than that? The new Cooler Master Set 120 features per key RGB lighting control, exclusive hybrid switches with the look and feel of mechanical keys found in professional grade keyboards, and a precision gaming mouse with durable Omron switches, and all at an affordable price. Get your click fix by following the link down below. Intel, it's been a really strange year for Intel. In fact, I don't find this platform to be the most compelling. It's obvious, it means nothing to gamers, right? This is not a gamer's platform by any stretch of the imagination. This is a content creator slash multitasker's wet dream when it comes to this many threads. In fact, this is giving us Xeon level of performance with the number of cores and number of threads, but we can actually overclock it. And that seems to be where the problem really is coming from, where once you start to overclock this thing, the power draw just goes through the roof. The deluxe edition right here, although decent, but I'm not gonna take any chances because I don't want a fire in today's video, but we're gonna be using the Rampage Extreme motherboard because of its beefier power delivery, which is exactly how it was communicated to me. This is not the most compelling launch this year to me. I'm actually more interested in the 8th gen CPU stuff because this is actually coming out a little bit later, very soon. So this is the Z370. Nick thinks if it was called the 370Z board, that I would have been a little bit more excited about this, but I'm actually excited about this because we are getting mainstream CPUs that have 6 cores and 12 threads, like the 8700K, which is in this box somewhere, I think. Look at this guy. Look how teeny tiny it is, and yet there's 6 cores and 12 threads in there. But I'm concerned because I don't want to have to rewire this thing for the power supply, because I don't know if you guys can see it. Look underneath here, look how nice and tidy these wires are, how everything's all zip tied and run out of, it's run out of sight, but not, if I have to redo all of this, that's gonna be a pain in the butt. It's almost like all of the rest in peace, call the fire department AMD jokes have made their way over to Intel. I was afraid of that. There we go. The problem was this hole is like the exact same diameter of these little retention nuts, so we gotta put that away soon. The Rampage stuff has always just been nice. I'm glad they got away from all the red. In fact, if we're gonna talk about power requirements, I've heard that the dual 8-pin is like pretty much required. The Rampage board doesn't even have dual 8 pins. It has an 8-pin and a 4-pin. So yeah, this might get interesting really quickly. This is where I kind of wish I had a mono block for this motherboard. I don't think there's gonna be one for a little while. I mean, it takes time for them to make them, but this is where keeping the VRMs nice and cool too is gonna be a problem, because I mean, the videos that have been making their way out regarding this have all said that the power delivery cables get pretty toasty. Got our isopropyl alcohol, good as new, nice and shiny. Smells like the doctor's office. So the socket's gonna look identical to every other one. Let's see, this is the one that says 2.6, so this is indeed the right one. You labeled it correctly, sir, kudos. You know what I'm looking forward to though? I'm looking forward to checking out the new Maximus that you're gonna get with the Z370. Pretty sure that that's gonna be a cool motherboard worth taking a look at. Not to mention the Maximus boards, right? They had the Extreme on the last one, which included the built-in water block. This is starting to look like an ASUS sponsored video. It's not though, it's not. I'll never get past the point where I care about the way wires look, even on things like test benches where they shouldn't care about being all pretty. I care. Did you hear that?
Yeah.
North Korea is firing! No?
No. Okay, they might be firing.
I love the edge lighting on the new motherboards though, because we have that on Threadripper also, and that's what's going to give us some of our lighting on our Threadripper build. I'm going to update the BIOS, and then I'll come back with the actual testing. Okay, so we got a couple things set up here ready to go. This is my watt meter. Man, this thing is old, ugly, and beigey. Anyway, idle right now, and you guys are probably not gonna be able to see this very well. The contrast is very poor, but we sit anywhere between the high 90s to the low 100s, about 110. I think I saw 117 for a second at idle, but this is just the system at idle, all stock speeds. I've also got real temp running right here. Hopefully the glare is not too bad, but I've got real temp running right here. It's not showing all the cores. Real temp has not been updated yet to actually be able to work with this CPU, but at least it gives us sort of an idea of what the core temperatures are looking like. There's also a tiny little readout right here in an OLED display on the motherboard itself that's giving us, and don't even bother trying to focus on that, Nick, you're not gonna be able to see it. It's gonna give us an idea of what the package temperature is. Interestingly enough though, I downloaded ASUS's own software, which is their tuning utility, to try and see what's happening here with temperatures and stuff. And you can see it's not showing, like, it's not really working very well, right? Max core frequencies, 0. Processor cache frequency, 0. Active core count, 0. Package temperature, 0. So even though this is a motherboard that supports this particular CPU, it doesn't look like this software has been updated yet. So that's why I'm using real temp. And we got our audio usage here just sitting right around 100 watts, 98, 104, 98, 105, 100, 103. So not too bad. And then we also have a GTX 1080 Ti Strix edition here that is sitting again at stock speeds. So let's go and get our base test out of the way. Let's go ahead and do, I'm gonna do a Cinebench run. I'm curious as to what the Cinebench score is and how mine is scoring compared to everyone else's. So we'll just run the CPU test, and our load right now is going up to 291, 288, 290, 287, 294, 296. Looks like 296 was our max draw from the wall. Remember, that's wall power, that's everything, not just the CPU, but that's the whole system right here plugged into this power meter. But we got a score of 3,364, which seems to be pretty in line with what everyone else is experiencing. So go ahead and save that score. It looks like our max temperature has reached about 40, 39, 44, 42, 43, and 39. And I looked at the core socket while it was running, and it said 44 on the socket. So temperatures, at least underwater here, are pretty good. So we're gonna go ahead and try a CPU test here on Blender. This is the BMW test that everyone pretty much uses. It's kind of the standard. And we're just gonna go ahead and click render here. All right, Blender's finishing up. We're still sitting right around 280, between 277 and 281 watts on this. So yeah, it didn't draw more over time as it got a little warmer. In fact, package is sitting at 36C. And if we look at real temp, our max temps again, 42, 41, 45, 45. So you can see we're in the mid to low 40s. Wish I could see all 16 cores, but again, it can't. You get the idea though. It also rendered that in 2 minutes and 27 seconds. So we can compare that when we overclock this. I'm gonna see what happens with some gaming now, or at least something like 3D Mark, which is a GPU stress test. I expect the wattage to be higher because I'm running a 1080 Ti custom PCB. It's a Strix card that's got some overclocking applied to it. It's gonna go to about 2,000. I'm expecting it to probably go up to about 400 watts on the meter if I have to guesstimate between the low load the CPU is gonna see, but the high load on the GPU. I'm expecting about 400 watts, so I guess we'll see if my predictions are right or not. And we are at 413, 406, 414, 410. So yeah, I'm gonna say about 415 wattage from the wall once again. So I actually saw 431 watts peak on the amount of power draw from the wall in a test like that. But here's a CPU test. It's going up to 253, 245, 275. So it's definitely all over the place, but no more than we were seeing with something like Cinebench or even Blender. So I think we have a pretty good idea of how much power the CPU is drawing at stock, which is actually not too bad if you think about it. And remember, that's total system power there. Let's see, our graphics score, 10,042, and our CPU score, 10,066. It's been a long time since I've actually seen a CPU score exceed a GPU score, But hey, that works for me. All right, you know what it's time to do now? It's time to overclock. So I've been talking to ASUS about this because I was concerned about the fact that we have an 8-pin plus a 4-pin power on this. And I've seen a lot of reports of people saying dual 8-pin is a requirement if you're gonna overclock this, otherwise you are going to just set your house ablaze. But ASUS has assured me that their VRM design is perfectly fine with the 8-pin plus the 4-pin. Now I don't have the tools or the equipment to verify that, but I'm gonna take their word for it, and if this goes up in smoke, then I'm assuming that they'll stand by their product and replace whatever goes bad. And this is not an overclocking tutorial, so this is just gonna be a quick and dirty because I wanna see what we get here with, I'm just curious as to what we can actually achieve. So we're gonna go manual. This little OLED display is the best thing that anyone's ever done for motherboards. The Q code thing is cool, but you always have to look up the numbers, but now it tells you, like on the little display, exactly what it's doing. So it looks like we might get a good boot on 4.5. Let's wait for everything to finish loading. But it looks like our idle has gone up from 90 watts to approximately about 178 watts. So you can see we've gone up significantly just by changing that. And we're not even at load. So we are almost at load wattage. Well, not almost. I mean, we're about 100 watts shy of load at idle now. But let's verify we actually. So we are 4.47 gigahertz on all 16 cores. So all 36 threads are getting that kind of power. Let's bring up our real temp again. Idle temps still seem pretty good. If this is accurately reporting, remember this needs to be updated. But I'm cool with it sitting in the high 20s at idle. We're pulling now 561 watts from the wall, so that's double. And you can hear the fans just immediately ramped up. And our temperatures, remember how they were at the mid 40s, mid to low 40s? Well, now it looks like we went to the upper 60s to the upper 70s, depending on the core. But look at the difference in score though, 4,427 versus the 3,364. So it looks like at least your performance is scaling with the power draw. But that's scary though, like my watt meter's getting kind of warm. I wonder if I have a bin chip, because 4.5 is one of those that like, they were like a good chip will hit 4.5. All right, blender time. Okay, here we go. It doesn't blow up or pop a tripper, trip a breaker, that's what I'm trying to say. It's right around 580 watts, but look how much faster that's going. Oh my God. Remember last time we had what, 220 or 2 minutes, 27 seconds? But we're pulling right around 585 watts from the wall. Remember this is an 800 watt power supply. So it's actually not as bad as I was thinking. We're sitting at 71 C on the package, so we have gone up approximately 30 C. About 30 C. And if you want an idea of the water temp increasing, look at the condensation inside the reservoir there. You see how we're starting to get some fogging? So the water temp is definitely increasing. But the air coming through the rad actually isn't all that warm. Not quite 600. Oh, there's 603, 605, 607. So it's going up. 610. So we saw a peak of 620 watts, but an average of right around 585. But we came down from 2 minutes 27 seconds in Blender to 1 minute 44 seconds with just a couple of clicks in the BIOS. So average usage right now, just while the GPU is doing its thing, came up to about 500 watts. I'm seeing, well, I saw 505, 515, but now it's down to like 493, 495, 498. So we came up at 100 watts just in gaming, right? Just under a gaming stress test like this. So the CPU test right now is drawing only 400 watts, 434, 447, right? So obviously it's not as stressful as something like Blender or Cinebench, which is expected. But look at our CPU score. It came up from 10,000, what, 100-ish to 12,534. And our graphics score came up a few points as well, about 100 points. Does that mean our 7980XE is bottlenecking? They actually recommended to have a fan blowing. Oh, ooh, that's warm, yeah. Before we do this, I think we need to plug a fan in and point it at the VRM. I forgot to do that. ASUS was like, yeah, we recommend if you're gonna overclock, you have airflow in the VRMs, and I'm water cooled, so clearly there's no fans there. Voltage override, I'm gonna set to 1.275. I'm just gonna leave it there. We don't really wanna leave it there because we don't want it pumping that voltage when it's at idle, but for the sake of testing, we'll just do that. I'm gonna grab a fan. Ta-da! It's literally just leaning there. I hope it doesn't ramp up too much and like mess things up. All right, so we're still at 1.275. Temps are sitting still right around where they were before. Man, does that thing like quickly ramp up. Yeah, we saw 85, 88, 88, that is. That's not gonna cut it. But the score, look at that, 4,442. That's too warm though. Right, look, 91C right there. All right, I'm gonna dial in the overclocks and we'll come back. So I reduced the wattage down to 1.25 and I increased the core temp or the core clock up to 4.7. I'm curious as to if we'll even boot. May I have finally won the lottery? 4.7. Now, if you guys are curious as to why 4.7 would be a big deal, even 4.5 is a big deal. Remember, this is a 2.6 gigahertz chip. Sure, it's got 4.4 AVX, right? But it's only 1 or 2 cores at the most. I'm running all cores overclocked right now, 4.7 gigahertz. Let's see. And I reduced the voltage down to 1.25. Let's see if this actually holds up. Man, that ramps up fast. Still getting hot though, 88, 89. 4,611. The fact that I've reduced the voltage and increased the clock and it's still at least past that, that's like what, a couple seconds to do this test? Let's just see how far we can go. This is crazy. I might have actually won a lottery for once. It's been a long time since I've had like a good overclocking chip. Like my chips have always just been like middle of the row. Brian, but you guys have kind of seen a little bit, he's forcing me, I say forcing me, he is being the devil's advocate on my shoulder saying, go for 5 gigs, go for 5 gigs, you can do it, go for 5 gigs.
Burn it down.
And we actually, so we got 4.8, which was good. We got 4.9 at the lesser voltage and Cinebench crashed, but the system didn't hard lock. So what I'm gonna do now is it takes approximately 4 or 5 seconds for Cinebench to do its test. I just wanna see if I can get 5 gigs in Cinebench. That's all I care about now. 5.18, wait, why did it jump up to 5.1? I put 50 as a multiplier, why are we at 5.1?
Don't question it.
I don't think it's gonna run. It can't possibly survive Cinebench right now. Oh,
no.
But again, it's not a hard lock. It's not a hard
Yeah.
If I can get that down to 5 where I want it.
We'll be okay.
So we've been playing around with this now for the last couple of, about an hour and a half or so, trying to get 5 gigs, we couldn't get it. I got 4.9 to run stable once, but I can't get it back. So I'm thinking I actually degraded the CPU down slightly in just the amount of testing, the amount of voltage we were sending at it. Ada64 just crashed on me. So at 4.8 right now, running 1.32 volts, which is highly unrecommended. In fact, Asus recommended I kind of tune around 1.275 and work it down from there because we're at the limits of water, as you could obviously see. I wanted to see what the power draw was in the worst case scenario. So we're sitting at 190 watts right now, idle. Again, total system power. And if I hit run on this, we spike up to 737, 744, 53. So 753 is where we went, and we came down slightly on the score again, 4,667. So negligible difference, but again, probably because throttling. See, all these cores are exceeding 80. That one's hitting 90. That one's hitting 97. Again, if I could see all 16 of them, I think we'd see more of them are throttling, which is to be expected because that much voltage and this speed is already approaching where we need exotic cooling, just because of the amount of focused heat that's in there. Remember, the die didn't get bigger. It's not like Threadripper where they got this huge die. It's still in a very small package, ladies. And so what'll happen there is you'll get much more focused heat. Now, what about something like Ada64, right? So Ada64 is a stress test, and it stresses stuff like system memory, CPU, cache, or FPU. So I'm gonna test just the CPU though. So I'm gonna take off the CPU, the FPU, the cache. No, I'm gonna take off memory. We'll just do cache, FPU, and CPU, and see it already detected that there was overheating. That's because this was actually running in the background when I did the Cinebench. So I'm gonna go ahead and clear all this. And I'm just curious, once again, what our temperatures are gonna do under this test, as well as our voltage. So 779 was where it started. 695, 658. So it's definitely all over the place, but as you can see, we are also thermal throttling slightly. And look, some of these cores, 105, 105. So yeah, we have definitely exceeded our cooling. So I dialed it back down to 4.5, and just to kind of show you once again, this is what you get. I also pulled the voltage all the way back to 1.25, so hopefully it doesn't crash. I also brought the memory back up to 2666. Probably could get 2933 out of it, but whatever, 2990, whatever it is. You guys know what I'm saying. But if we compare now, we are getting 590 9 watts pulled from the wall. And you can see our temperatures are much more acceptable. Our score came down, of course, 4,386. So we lost about 300 points, just under 300 points. But you know, you're gonna lose a whole lot more points if you blow up your chip simply because you gave it too much voltages and stuff. So anyway, that's been my 2 cents about this chip, because I was really most concerned with power draw, temperatures, and what overclocking was like on this, because we had seen rumors that it could be up to 1 whole kilowatt or 1,000 watts pulled from the wall when overclocking this. Especially on LN2, I think the guys that hit 6 gigahertz were pulling 1,000 watts. And we saw that by just going from 1.25 to 1.32, our voltage or our wattage went from roughly 600 watts to 750. Just that little bit, yeah, it's pretty exponential. But yeah, 4.5 on this chip, you could run this every day and not have any sort of problems. With that said, I'm gonna go, guys. Thanks for watching. As always, I'll see you in the next one.